I am meant to find parametric equations for a line through a certain point that is parallel to another line described by some parametric equations. Okay, so this set of equations describes a line in the direction, well, I can just read off the direction by looking at the coefficients of t. 2 is the coefficient of t, this function describing x. Negative 1 is the coefficient of t in this equation describing y. And 3 is the coefficient of t over here. Oh, that's right, I have some music playing now. Because it's a rainy day, and I just thought it'd be fun to have some music, mostly for my own sake. Okay, so that is to say this line right here is in that direction, and I want to have a line which is parallel to this line, meaning is parallel to this direction, through that point. Okay, so this right here, this is describing that line. I want to say is the range. I want to make sure that I'm talking about the right thing here, of the function r of t is, now I want the direction 2, negative 1, 3 times t plus the initial point 3, negative 2, 1. Okay, and from there I could say and is described by, this time I could say x is 2 times t from here plus 3, and I see that that is a different algebraic expression for x down here than up there, right? 1 plus 2t and 2t plus 3 are quite different. For y, I have negative 1 times t minus 2, and that is indeed different from this. I have a negative 2 instead of a positive 2, and this last guy, oh, I'm sorry, y is equal to, there we go, and z is equal to 3t plus 1, and that is different from 3t. Okay, so these are the parametric equations describing the line that we wanted, the one that's through 3, negative 2, 1, and in the same direction as this guy. I just picked off the direction first. If you were pretty slick, you could have skipped this parametric equation and gone to the parametric equations pretty quickly, but I didn't want to do that too early in the examples. We're only on number 6. And I will spend maybe a minute or two drawing what's going on. If you don't want to see that, feel free to jump to the next video or do whatever else you're doing, but I'm going to just listen to music and draw some math. Okay, that first line, let's see, the first line right here seems to pass through the point 1, you think of it as the initial point, 1, 2, 0. So 1, 2, 0 is this point. So the initial point of this line that we were comparing to is 1, 2, 0. And the direction of it was 2, negative 1, 3. So let me draw 2, and a negative 1 would go off in this direction. Negative 1, and then a 3. 1, 2, 3. Okay, so do my usual thing of drawing a collection of parallel lines to get me to, let's see, I need to draw another line parallel to this guy. There we go. So 2, negative 1, 3, looks like that. And I'll draw another copy of him starting at 1, 2, 0. Make sure I get about the right length. Let's see. Tip of the pen down to where it says med, or medium, I suppose. That'll take me about here. Maybe a little bit too long. whoops, and my line that I started out with here in blue, this one, he looked like that. Okay, so that was the line described by the book, and then I came back and described this other line that passed through 3, -2, 1. Well, let me work on that now. So 3, -2. So here's a 1, 2, 3. This time all the way out to -2. I suppose that would put me about there. And 3, -2 will be over here. And then 3, -2, and then up 1. Up to about, I don't want to draw another parallel line here because things are getting noisy. That would put me right about there, I think. 3, -2, 1, the point. And I use the same red direction from here. So I'll draw a copy of that vector emanating from here. Let me try to make that parallel. Okay. So there's my initial point and my direction, and the line, this one I will draw in green. There we go. Okay. So we can see that these really are different lines, but they have the same direction. And so to recap, what I did is I was supposed to find a different line than the one described here, but one that was in the same direction. So I picked off the direction. Actually, technically, this is not a direction, so maybe I'll go back and just fix something real fast here. The direction of, right? I mean, this is not a unit vector, and technically, we're supposed to reserve the word direction for unit vectors. Okay, so I picked off the direction of this guy in the form of a vector as a direction, and that was this guy right here. So I looked at this blue line and I said I can figure out the direction from the parametric equations. And then once I figured out that direction, I attached that direction to a new initial point and gave me a parametric description of this. One last comment. Of course, you know that I like to explicitly point out the difference between equations and functions, and I think that these parametric equations really ought to be thought of as parametric functions. A parameterization really is a function. And so even though the textbook said x is equal to 1 plus 2t, etc., I would really like it if they said that this was a description of 3 different rules of correspondence for 3 different functions. X, a function from the real numbers to the real numbers, y from the real numbers to the real numbers, etc., and similarly down here. If you tuned in to the full video, I'd like to thank you for spending this beautiful less than 10 minute period with me, and invite you to the next video. See you soon.